Hello friends, today we'll be learning something about hydraulics problems. So this is an IFE UK part 3 grid examinations in which we have pressure and height relation. Pressure and height relation is nothing but it's the two type of first of all there are two type of energies. First is the potential energy and the second one is the kinetic energy. So pressure and height relation, it's nothing but the relation of pressure and height with respect to potential energy of your water. So what happens? It's just a calculation in which it's your potential energy equation is what is it? Its potential is equal to mgh, where m is mass, g is the gravity, h is the height. So what happens? The same thing is repeated, but this time around it's a pressure which is supplied from your pump casing. P is equal to rho GH, where P is in pressure in Pascal, rho is the density of a fluid, normally 1000 kg per meter cube for fresh water. G is the acceleration due to gravity, constant at 9.81 meters per second square. So what happens? And h is the height or depth of a fluid in meter. So what happens when we see this potential energy mass into gravity into height? Mass per volume is a density. So once you see P is equal to density into gravity into height, m upon v into 9.8 meters per second into h, so it gets cancelled out, so it becomes 9.8 meters per second square into height. So meter and height get cancelled out, so it becomes h by 10. P is equal to h by 10. So this is a formula. P is equal to h by 10, where P is a pressure in bar, h is a head in meters, head or height. So pressure loss, now the second thing, frictional loss formula. PF is a pressure loss due to friction in bars, is equal to 9000 F small l capital L square divided by T raised to 5. So what is it? It is nothing but a frictional loss. PF is a frictional loss. When at any incident we are say using water as an extinguishing media, we are using hose pipe. So frictional loss depends on many factors. First of all, friction factor. So friction factor depends on your length of your hose and diameter and many things. Means every material, its material is very important. Length of the hose in meter, flow rate L, length of the hose is small l, flow of the rate in liters per minute, and D is the diameter of the hose in millimeter. So this is extremely important on an incident, fire incident, when depending upon which you can calculate the amount of water which will be poured at an incident. Flowing through a nozzle, flow through the nozzle. L is equal to 2 by 3 T square under root P, where L flow rate in liters per minute, diameter of the nozzle in millimeter, and pressure in bar. This is also an extremely important because what happens? Your nozzle is smaller, so you can calculate the length and hose of an frictional loss you can cancel out, but After that, you're using a various size of diameters of nozzle. So depending upon that, you can calculate amount of water being poured out. And the third one is the water power. So WP is equal to 100 LP divided by 60. Water power in watts.
सर आगे सर बोलो 9 का क्या होना है